of the respective fields so that not only our students but everyone who join us get benefits of their expertise. So today's our session is based on the applications of modern algebra in day-to-day life. The term algebra comes from the algebraic literature, which means the reunion of broken parts. It is one of the broad part of mathematics with the number theory, geometry, and analysis. So in elementary algebra, we usually deals with the equation systems and how to solve the equations and how to find unknowns in the equations. But in the modern algebra, we have to deal with the group, ring, and fields. Okay, now without taking much time, I welcome our respected speaker, Dr. Dhananjay Day. Welcome, sir, and thank you for sparing your precious time with us. And I also extend my hearty welcome to my dear colleagues and everyone who joined us on this on this platform. Okay, let me shed some light on education and academic achievements of our expert. Dr. Dhananjay Day obtained his graduation in mathematics honors and master's in mathematics honors from Jadavpur University. In year 2000, he joined DRDO, a renowned organization of India, as a scientist. During his services at DRDO, he also completed doctoral degree on the thesis titled Multivariate Polynomials and its application to the cryptography. To fulfill the passion of teaching and guiding the young students, Dr. Dhananjay Day took voluntarily retirement from DRDO and recently joined IIT Lucknow as an associate professor in the Department of Mathematics. So his research interest includes design and analysis of block cipher, hash function, quantum computing, and quantum cryptography. He has published many research articles in various reputed journals and also guided master students and doctoral students. He is the member of board of studies of different reputed universities and reviewer of many esteemed journals. Now, without taking much time, now I would request our honorable speaker to kindly start the today's lecture. So, sir, mic is over to you.
Good morning to you all. I hope I am audible and my screen is also visible, but
Yes.
I am unable to unmute my video. So whether video is required or not, I don't know. Otherwise, I can just talk without this video option.
Sir,
No,
as
sir.
we are with no issues.
Yes. No,
Okay,
sir.
so
Video is not required, sir. You can proceed like as it is.
yeah, okay. So first of all, thank you very much for inviting me for this type of webinar. Actually, nowadays, you know that we actually have such type of pandemic. So this type of activity actually motivates not only means the students, but also the speaker also to share their knowledge related to this field. So today the topic is very relevant, and since it is organized by the Department of Mathematics from your university, and one of the most important topic that modern algebra, how this modern algebra actually plays an important role nowadays of our secure communication. So this is a very relevant topic nowadays. And before, if you notice that, say before 1970s, nobody actually knows how this modern algebra and number theory plays an important role in this type of our day-to-day activities. Throughout this session, actually, I try to give certain examples from which you actually see that this type of modern algebra actually you are using in day-to-day life without either knowing it or unknowingly you are using in your day-to-day life. So before going to this talk, what I actually refer that first I should go for the few disclaimers. So basically throughout the presentations, all the pictures are taken from freely available websites. If there is a reference on a slide, then all the informations most probably taken from that means reference only, whether I am using that quotation mark or not. any mentions of the commercial product or reference to a commercial organizations mainly for your information. I am not recommending that that product is basically the best, or I am not endorsing such type of product. Okay, so this is the outline of my talk. First, I will introduce the subject, then how actually algebra plays an important role in cryptography. You will find that this cryptography actually gives certain type of activities for your pure algebra. Not only pure algebra, but mainly that pure mathematics, that modern algebra, linear algebra, as well as number theory. But obviously, for the today's topic, I will mainly concentrate on the applications of modern algebra only. So, what we actually do in the modern algebra, uh, I hope there are few first year students also. So, for them, actually, this is basically the concepts of set theory along with one or two binary operations defined on it to form such a type of structure, and how those structure actually plays an important role, and other activities using this type of structure what we can do. So this actually covers in this whole modern algebra. So you will find this type of topics. They are in group theory, ring theory, polynomial ring, field, finite field, and lot of subtopics are there in this modern algebra. We will mainly focus today ring theory or finite field in this type of application. Okay, so we'll see that algebra in symmetric key scenario and algebra in asymmetric key public key crypto system. If time permits, I will actually give you some security tips to practice in your online communications. So because I don't know means whether you are actually opening your session for this semester as a physical class or you are actually going for the online session. So if you are actually following this whole semester throughout that online session, then few security tips you require to follow such type of security notions. So if time permits, then I will go for this. Otherwise, I will stop my talk after giving the examples of algebra in public key crypto. Okay, and please feel free to means ask questions. Don't wait till my lecture is over. If you have any questions or query, you can either write in the chat box, or you can actually just stop me, unmute your mic, and you can ask the question. Is it clear?
Yes, so my dear students, you can ask your questions during the session, and after the session, we also have the question answer session, and you can also ask there.
So
sir,
I hope means this session will be till 11:30. So what
yes,
I
sir.
can actually do means I can stop my talk at 11:15. Then we will have 15 minutes question answer session also at the end. Will it be okay?
Yes, sir. So, students, if you have any question, please write down your questions. If you are on YouTube, then write your question on the comment box, and I also request other students to write down their questions and send to your respective mentor or your respective faculty, so that our faculty members recite your questions. So, yes, sir.
Either they can recite the questions, or means if there is a representative faculty member, they can actually just type the questions in the chat box. So while actually discussing the topic, I can immediately answer those topics. Otherwise, I have to come back to those slides. Then means it will be difficult. Otherwise, means it's up to you. You are free means to ask questions at any time from
Yes, sir.
my side.
There are representatives,
Okay.
the faculty representatives,
Okay. No issue.
who will recite the questions to you after
Yes.
the end of the lecture, so that it would not be any interruption between the lecture.
But I means prefer to actually the communication should be two ways. Okay, so what you
Okay.
actually follow, there is no issue. I can
Yes.
directly go for mono means mode.
Okay,
Okay.
sir. Then, sir,
Okay.
I'll give the access to the students as well, so that they can unmute themselves and they'll ask the questions while in the lecture also.
They can actually, those participants watching through this Zoom link, they can actually write the questions in the chat box. I can see the chat box, so
Okay.
I can immediately answer those type of questions.
Okay, sir. Okay. Okay. Thank you so
Okay,
much.
thank you. Okay, so first, what are the applications of pure mathematics? So normally you will find there are a lot of applications of pure mathematics, something like your algebra and number theory in cryptography. And nowadays, cryptography plays an important role. So our few applications of mathematics have achieved such type of social importance. So even not only your technical magazines, nowadays you are actually reading few news from your day-to-day newspaper that certain country are attacking other states and actually impact the elections, such type of results. So these are actually in your day-to-day activities and day-to-day news nowadays. So most of the time, mathematics does not provide a focus on blockbuster movies, but in the case of cryptography, obviously it does such type of effects. So you will find this type of movies, Enigma, Skyfall. Those are based on basically the concepts of cryptography. Even in your Bollywood also, you will find that movie Rosa and 16th December. So those are the movies actually use the concepts of cryptography and actually demonstrated such type of attacks. Television series, obviously there are this type of television series, and also you have that best-selling novel as Dan Brown, that Digital Fortress. So these are the actually applications of pure mathematics. So nor does pure mathematics normally end war or disturb world leader. However, this applications of cryptography does such type of impact. Something like you have heard about that China and North Korea are actually attacking other countries to reveal their secrets. Also, even in Russia, they actually intercept certain lab, biological lab, to how they are actually experimenting this type of or designing such type of means antibiotics or vaccines for your COVID-19. So such type of scenario nowadays are very common. So you will find that the role of algebra plays in this type of activity to make this type of communication secure. Okay. Now cryptography is like something like you can think of like your antibiotics. So many a times you are taking antibiotics without knowing the exact effect it will do. So you can breeze through your life using cryptography without even being aware of it. A little bit of knowledge about cryptography can make a big difference in your life. That is, for today's scenario, it is very important point. You will find that critical role of cryptography plays supporting in your everyday life. By learning what cryptography does and how it works, you will actually acquire great confidence in reasoning about your own personal digital security. So we all are in digital mode nowadays. So what are the security behind this? So you will actually find such type of applications of algebra. Now, before going to the applications of algebra, what I will actually, since we are in this online mode, so our every communications are happening through online. So what are the main component of a communications process? So what you want to communicate first? So you want to communicate either text, speech, or facts. So there are basically, it may be in the form of analog or it may be form in the digital. Something like I am speaking in front of my camera, in front of my laptop. So I am actually taking this input something like analog. Now this analog speech actually using some encoding technique, it will actually convert it into digital form. That digital form, it may be compressed. So that digital form actually reaching at your end, either you are watching this lecture or webinar through your mobile phone or your laptop. So it will actually go from this end to your end using certain type of parameters. So first, this is your input, what you want to communicate. There is a standard technique of encoding. So there are a lot of maths involved here also. And then this encoding actually compress the data, something like you have heard about that JPEG or MPEG format, something your any YouTube clip or any means your image. So these are basically the compressed document of the original image. Then, since you know that there should not be an ideal noise-free channel, so the channel which is actually I am communicating through this maybe there are lot of noise in this channel. So at the receiver end, to remove this type of noise, we require certain type of maths. So there are a lot of applications of finite field in this error control coding. So we require some error control coding, so that after that, depending on our channel, whether it's basically going through the wireless or wired, so depend on this, we use that model. Even you notice that in your home also, you are actually have different type of modems if you have wired connections or wireless connections. So according to that, we actually send this signal either through wired or wireless. Now, after receiving this signal at your end, your modem actually does that part, that it will directly control this block. So from this end, what you actually apply, you apply error corrections technique. So there are also a lot of applications of finite field, and you actually just come back to this compressed data. Then from this compressed data, there is a standard technique to go back to the original text or files. So this is the whole part of communications. But this type of communications, anyone or any attacker can actually listen or intercept. So what is the role? Obviously, the role of cryptography plays an important role for our secure communication. So please notice that this is important. If you want a secure communications, you require cryptography. Okay. So what is the extra component I have added here? I have added here this extra component that basically we are actually using this a block, something like we call this is encryption. Forget about the term encryption for the time being. Just for your convenience, you can assume that this is basically a function which takes two input. One is your input message, which is coming from that compressed output from that block, and you can take a key. So this is a function which depends on two input. One is your key, another is your message, and it converted into a different form of that text. So that we call that ciphertext. Okay. So this plays an important role. Why? Because if an attacker does not have this key, so the attacker cannot compute from either directions, either from this directions or from this direction. Because from this end, everything is open. Any attacker can actually intercept our messages. There is no restrictions. Actually, we have that we restrict our attacker to listen the communication. Okay. So this is actually an important part, and this is the part where lot of maths are used to design this box. So this is a functions. You have to design this type of functions in such a way that without knowing the key, nobody able to compute these functions in either direction. Not he or she will able to compute the direct functions or the inverse functions. So this is the main important part of this secure communications, and this is basically the maths where you will have lot of applications. Okay. Now there are few extra steps we actually do, that is steganography. So in steganography also means actually we hide the message inside of either image or in a video. So these are the techniques. So for the time being, we do not require steganography. Now, before going to discuss the applications of maths, here actually we require few terminology. So what are those terminology actually we will be using throughout the talk? So this is basically the overall concepts of cryptology. Cryptology consists of two branches of science. One is cryptography, another is cryptanalysis. So what is cryptography? Cryptography is a science which deals with how to achieve pain. Yes, This pane is basically your privacy and confidentiality, authentications, integrity, and non-repudiation. So these are the basic 5 properties we can say. Using this cryptography, actually we can achieve this type of properties. Now, cryptanalysis, what is that means? Basically, this is a science which deals with how to defeat of achieving pain. So there is basically a lot of war between the designer and the cryptanalyst. So we say that who actually build this type of system, we use certain type of this, so we will use the terminology cryptographer, and who actually attack those systems, we use the terminology cryptanalysts. Okay, so next, actually the single line definitions given by Refest, that cryptography is about communications in presence of adversary. So how you can actually communicate in presence of adversary, that is basically your cryptography. Okay, so cryptography supports multiple goals, obviously not only restricted to just 5 properties. So you will have this confidentiality, data integrity, privacy, availability, and non-repudiations. Okay, so these are the actually attributes we have using this cryptography. Okay, now there are basically 2 types of cryptography broadly we can divide. One is secret key cryptography and another is public key cryptography. So what is that concept? Just for the time being, you assume that you actually just lock your room, and if you don't give the key, so no one able to actually enter that room. Okay, so you notice that if you are actually put a lock in a room, then what will happen? That same key actually required to enter that room. Okay, so there should not be 2 different keys to actually unlock the to actually open this lock. So just remember that at the sending end as well as at the receiving end, we actually require a copies of this key. So if you have a lock, then you should have at least 2 same copy of this key to enter that room. Okay, so this is basically the concept of secret key. Means the key is used by both sender as well as the receiver will be either same or similar, meaning you can actually compute this any key from the other efficiently. But such type of, what are the disadvantage of this type of system? Suppose I want to actually talk to you. You are now basically I am noticing that there are 83 participants. So I first have to go to each 83 participants to give my key, and then I can able to communicate. So that should not be the scenario. That is basically a disadvantage. Now what we can actually go, we can just go through the public key cryptography. What is that mean? Suppose I can have your email ID from your university. Now, knowing your email ID, I cannot go directly to your password. So just remember that my email ID is open to each one of you. Anyone can send me the message through the mail, but without knowing the password, nobody else actually read the message which I received in my inbox. So this is a different concept that's called public key cryptography. Here are 2 different keys. One is your public key, another is private key. So public key, I can make it public. Something like my mail ID is open to all. But knowing my mail ID, you should not be able to get my password. So that is the concept of your public key cryptography. So this type of scenario, actually the drawback in the symmetric key cryptography, that I have to go to the each individual first share the key. That should not be possible. So what I can do, I can send this webinar link through my email, to each of the participants, and just using your password, you can actually join this webinar. Okay, so this is basically the, in practice, we require both. But after joining, if this whole session is encrypted, then that encryptions actually are symmetric key. So symmetric key is very fast, but public key is basically very, very slow. So we use both, and that is called hybrid public key crypto system. Okay. Okay. So now I can actually move to the assumptions. Obviously, every science is based on certain assumptions. Okay. So what are the assumptions in the case of public key cryptography? So the main assumption is basically you design that functions. Just remember that encryption block. Okay. So design your that encryption functions. The assumption is everything is known except the key. So functions is also open to each one of you or the adversaries, but without knowing the key, the adversary cannot actually get the means input or output from that function. So I can make my functions public, but if I don't give the key, then no adversary actually able to compute the output from that function. So this was given by Kirchhoff's principle, and this is basically the only assumptions in this crypto. Okay, so now you actually notice that there are a lot of applications of cryptography in your day-to-day life without knowing it, or means unknowingly you are using in your something like you are using Zoom. Even in Zoom also you will find such type of URL. So here if you go to this URL, that HTTPS, I hope this is visible. And now if you just move to the technical details, what is written? Connections is encrypted. TLS, that is transport layer security. AES, advanced encryption standard with 128-bit key. So there are a lot of applications of finite field to design these functions. It will be applied with the Gallo counter mode. Sorry. Then SHA-256 is a hash functions. There are a lot of applications of random permutations and Boolean functions to design such type of functions, and we implement this. This is basically the TLS 1.3 version. So without knowing this type of concepts, actually we are using this type of encryption system in our day-to-day life. This is one example, and the detail is given here. That TLS, AES 128, GCM, that Gallo counter mode, and SHA-256 is used for this type of secure connections through your Gmail. Okay. Similarly, if we go for your online banking, so in your online banking, if you notice that this connections is basically secure with TLS version 1.2. If you notice this, just notice my cursor. So TLS 1.2 here, and here in TLS 1.2, the difference is basically we require few public key system, that is elliptic curve defilement key exchange, RSA, and AES. I have already mentioned. 1626 6002. Please unmute. Yeah, there are basically one. Please unmute it. Okay, otherwise I have to means okay. I have done that part. Okay, so now coming to this part, technical details related to your online communications. You will have that elliptic curve defilement key exchange. So there are a lot of applications of algebraic geometry here, and then RSA. There are a lot of applications of your number theory, or we can say that certain type of rings in this case. And even to attack such type of systems, we require a lot of linear algebra. So without knowing such type of applications, we are actually using our day-to-day communications or day-to-day secure communications. Now, cryptography is there obviously, and you will find that TLS 1.2 in banking system, we are actually using 256 instead of 128. Otherwise, normal communications in TLS 1.2, we use AES 128. Okay. You notice the importance of your Aadhaar nowadays. In your every connections, you require Aadhaar for your this. Now, what are the components here in the Aadhaar also? You will find that this type of maths we used to communicate our entire data in the Aadhaar. So we use RSA 2048 nowadays and AES 256 to communicate our data. So there are a lot of applications of finite fields here, and there are a lot of applications of ZN, ring ZN here. So we will actually discuss at least one or two applications of such type of maths, so that you will actually notice how this type of maths actually used to design such type of function. Okay. Now, cryptography is everywhere. Something like your in ATM, how we can actually achieve that 4-digit PIN, all HTTPS site I have just discussed now, and then remote login nowadays, mobile communications in your GCM or any wireless network. However, that cryptography is not there, obviously, in your university. So if you go to your university site, you will find that there is a lock with red line. And if you click that lock, you will find that the technical details connections is not encrypted. What that means, that information sent over that internet without encryptions can be seen other people while in the transit. So any communications from you to your university site is basically open to all. Okay, so it is recommended, please go for TLS, at least TLS 1.2 or TLS 1.3 for your institute site. And I hope you are not taking fees using this site only. There should be a separate URL for your taking admission fees or any semester fees you are taking through other portal, I hope. Okay, so now coming to the one, at least one example for every cases. So I will try to cover this part so that you will actually notice how maths is used to design such type of functions. So I have covered the importance of the communications and importance of cryptography for secure communication, and I have just gave you few examples, something like AES and RSA. So we'll actually notice how this type of functions is designed using algebra or number theory. Okay, I will mainly focus on algebra today. Okay, so first, this ring, I don't know means whether there are many first year students. For this, what I can actually say. Okay, if there is any options, or otherwise, just for the time being, assuming that Z26 is basically, you can take any two member from this Z26. So Z26 consists of elements which basically 0, 1, 2 up to 25. So take any two elements. Additions means if you add those two numbers, if that number exceeds 26, then what you will do, you will just divide that number, that output, and take the remainder. So that is your this plus notation. And what is the multiplications? So take any two elements from this set, and if the product is exceeds that 26, then again you divide that number by 26 and take the remainder. Something like, suppose I want to multiply 7 and 5. So 7 and 5 belongs to Z26. If I multiply 7 and 5, I will get 35. So 35 is obviously greater than 26. So what I have to do, I divide 35 by 26. Then what will be my remainder? My remainder will be 9. So the output for this 7 and 5 is basically give you 9 in this ring. So you will actually notice that this is a ring, and obviously you will find that. Just for the time being, now assume that I'm just designing this type of functions, that Z26 to Z26 a mapping. What are the mapping? Just take any input, something like your PI is the input, then pi actually maps to, there is a different actually notation. This is not a simple arrow, this is a maps to, means an element actually move to this as an output. So if this is your input and this will gives you the output, so this is basically a times pi plus b mod 20. I have defined the multiplications and additions, you know, usual addition. Just do these operations in a simple arithmetic. If that results actually greater than 26, then just divide that result and take the remainder. So this is a very simple function. Now, if you don't know A and B, suppose I keep this A and B secret. So knowing the output, it will be difficult for you what should be the input. So that is the concept of that key. So here is basically your key is A and B. And obviously remember that if this is a function and if you are sending this output to the uh, receiver end, then what will happen? Actually, the receiver end should get back to the message itself. So this function should be inverted. So please remember, while designing such type of functions, that function should be inverted. Okay. So this is an exercise for say your second year, third year, or PG1. How many functions I can have of this type that I am taking A and B from Z26, and so that this function should be 1. So this is an exercise for your means second year onwards students, not for the first year. Okay. So here I can just give you one example. Suppose I want to encrypt a message this college. So what will happen? I am taking this A as 5 and B is 4. So just replace your A by 0, B by 1 and so on, so that you will replace Z by 25. So actually I convert the each English text just by number. So your C will be 2, O will be 14 and L is 11 and so on. Using this type of encoding schemes, so this is called your encoding schemes. If you remember that diagram I have shown at the beginning of my talk. So from here you will find what will be the output for 2. So multiply 2 times your 5, A is 5, so 2 times 5 is 10 and B is 4, so you will get 14. Now coming to 14. So if I go for this 14 as my input, so what will happen? 5 times 14, you will have 70 and then this 4. So this is 74. Now if we go for 74 and just you divide 74 by 26, you will notice that you will find 22 as your remainder. So 22 will be your output. Now what will happen? This is your exact plain text. If I use this type of functions to convert this plain text into a different form, so you will get this plain text. Now if I send this plain text and you notice this, so if you don't know what A and B is, A and B are actually, so you cannot go back to that. This word actually belongs to this college as a plain text. So this is the basic concepts. We use such type of rings in our communication, but this type of communications actually designed before World War One. Okay. Now here is a drawback. What is the drawback? If there are few repetitions in the word itself in the input, then you will notice that this type of repetitions will be there in the ciphertext. Something like your LL is here, so HH is. Similarly, if E is here, if E is replaced by Y, then sim E will be replaced by Y itself. So this is a drawback of such type of function. So what was the letter design? You move for the polyalphabetic cipher. So these are called monoalphabetic. Why? Because each character is actually replaced by same character throughout your plain text. Now in the case of this, so basically what is your encryption scheme? You take this ring that, and you actually notice that if I design a matrix is of this form, you take the plain text in the form of, for the time being, assuming that you are actually using 3 cross 3 matrix as your key. So these are the matrices and entries are coming from Z26. So please remember this notation. And for the first year students, just means forget about the notations. You just remember that you take a 3 cross 3 matrix where each entries are coming from either 0 to 25. Okay. Design such type of matrix and then break your plain text into 3 character block. So this is your plain text P1, P2, P3. If you multiply this is a 3 cross 3 matrix and this is 3 cross 1 matrix. So what will be my output? I get an output of 3 cross 1. So 3 cross 1 is basically your ciphertext. So this is your ciphertext. Now notice that in this type of design, what I have to remember? I have to remember that this type of functions should be invertible. So the question is, this is a question for all your second year and above students. How many invertible matrix we can find over Z26, say 3 cross 3 matrix over Z26 under modulo 26. Okay, so this type of actually possible functions you can design to communicate. So there are huge actually, means if you compute those type of, so these are exercise. So this is called Hill cipher. Now what is the advantage of this? Now if you notice that this is your plain text, eternal light. So eternal light, I divide that eternal light by this 3 character block, and what I, if you notice that ETE, so this is my plain text, and if I choose this is my key matrix, and key matrix is unknown for the adversaries or attacker, then what will be the ciphertext for that? Actually I will receive ciphertext as LXG. Now remember that here first E is replaced with L and third E actually replaced by G. But in the case of previous that affine cipher, if my first E is replaced by L, then every E should be replaced by L only. So these are the advantage if you use this polyalphabetic cipher. And this type of system obviously used before World War One, but not the case that this is always used before World War One. Even in means say 1960s and 1970s also, Vietnam actually used such type of systems in their military communications during their French and American wars in Vietnam. That you know that Cold War. Okay, so that time actually they use such type of systems because the number of alphabets in Vietnam are more than this normal English text. Okay, so these are the basic introductions of your classical system. Now coming to one algebra means applications of modern algebra in your modern communication system, something like AES. I mentioned this AES many a times while we are actually showing you this connectivity with Google, Online SBI and other activities. So this is called Advanced Encryption Standard. It was standardized in 2002 itself. And this is a block cipher. So obviously we actually, something like your Hill cipher, what we did that we actually divided the plain text into 3 character block. So here this designer obviously are from Belgium. So they are famous for their design, not only this AES, also in the Sathri. This actually designed through the worldwide competitions by US. And the main maths actually they used, this is basically a byte oriented cipher. I hope you know that byte oriented cipher means your implementations will be done by a byte by byte. So what is a byte? A byte is basically consisting of 8 bits. So how you notice that 8 bits? So that 8 bits actually a form of an element of a finite field. So I don't know means whether the second year students also gone through this type of structure. So maybe it will be useful for your third year or PG1 means student. The notations is basically your field. So if you notice this, the GF2x, what is that meaning? You take collections of all polynomials whose coefficients are coming from GF2. GF2 means basically the smallest field which consists of only just 0 and 1. So you take all those polynomials whose coefficients are basically 0 and 1, and what you do, you then divide that polynomial something like your Z26. Just remember that Z26. If that polynomial, degree of that polynomial is greater than or equal to 8, what we will do? We will just divide that polynomial by this polynomial and we will take the remainder. Okay, so what will be that meaning? So this is if I divide any polynomial by this polynomial, what will be the degree of my maximal polynomial as a remainder? I will get 7-degree polynomial. Now, in a 7-degree polynomial, how many coefficients are there? In a 7-degree polynomial, you will have 8 coefficients. Okay, so 8 coefficients, something like A0, A1, A2 up to A7 x to the power 7. So you will have 8 coefficients, and each coefficient, the options for this, the choice for a coefficient either is 0 or 1. So for the each coefficients, the choices are 2. So you will have 2 to the power 8 total number of elements in this polynomial form. So that's why we notice that number of elements actually indicate by this, and this actually forms a field. Why? Because this actually, the choice of this polynomial is basically irreducible polynomial. So this is basically for your third year and PG1. I'm just giving you just the flavor how this type of maths actually used in designing our modern cryptography. So this is an irreducible polynomial, and you know that ideal generated by this irreducible polynomial actually give you the maximal ideal. And a ring, this is a ring quotient with that maximal ideal give you a field. And the number of elements of that field is basically finite. So that's why we say that this is a finite field. Okay, so these finite field structure actually used to design this advanced encryption standard. I am not going to discuss more detail related to this. I can share my slides. If you are interested, you can just go through the detailed maths behind this. So what are the structures and other things? There is a beautiful structure of this finite field. You cannot have such type of structure in your characteristics 0. So any finite field actually have the characteristics of P. So P is basically prime. Okay, so I'm not going to discuss this part. So this is actually, I can divide the whole abstract structure with 2 binary operations. So starting from ring, you will find that this is a very beautiful structure in between this ring. So we can have such type of different rings in as a whole structure. Okay, so this is mainly for your third year and PG1 most probably. Not for even, I don't think whether you have covered the ring and field in your second year. I don't know. Okay. So these are the actually applications of this. And now what are the system? Actually, I now can directly go to the system. How actually you convert your data 8-bit or 128-bit to this. I'm not going to discuss this part also. You will actually have, if you are interested, you can just go through the slide. And slide is explicitly written, so I hope you don't have any problem while just means calculating each and every steps. So here the system is basically AES 128. So basically you have 128-bit block as an input, and we convert this 28-bit block just like 16 byte. So basically we divide further it into 8-bit block. So you will have 16 bytes, and those 16 bytes actually represented using the matrix notations. And for different, there are 3 types of actually AES. So you have noticed that in your Google, actually we are using AES 128, and online SBI, we have used that AES 256. So these are the different kind of AES based on the size of the key. And if we are using this AES 128, we actually repeat the functions by 10 times. And if we are using AES 256, so we actually repeat the internal functions that we say that rounds. So this repeated by 14 times. Okay. So here are the structure. This is a very simple structure. First take 128-bit plain text. Okay. Then add round keys. So there are 128-bit keys, something like for your Google. Then we have a S box, means you will have a certain type of substitution box. Each byte will be substituted by a particular design or particular elements. Then you have shift rows, mix column, then add round keys. So this consists of actually just a single function. You repeat these functions by 9 times, then at the end you will have a different function where you can notice that this mix column is not there, everything are there. So except this mix column, you will have everything here in the last function. So this in total, we say that this is a 10 round AES. Okay. So what are the structure actually? So I actually divide this 128-bit block as an input by 8-bit byte. So this is basically the structure. My first byte will be here, second byte will be here, and so on. So I can arrange this 16 byte in this type of matrix. I XOR with this key, then I will apply the S box. S box, obviously there are a lot of maths, and these are basically the maths related to your GF2 power 8. Okay, so if you notice that this type of 3 functions actually are there to design that S box. So a lot of applications of finite field in security of this AES. Okay, and then mixed column also you will have this polynomial concepts or matrix multiplications. So here you notice that 02 is basically represented in the hexadecimal format. So in hexadecimal 02 means it will give you a 7-degree polynomial. So first 0 is actually basically 0, 0, 0, 0, and you will have this 2 is in hexadecimal form. If I converted it into binary, then I will have 0, 0, 1, 0, 1, 0. So your 02 is nothing but your x as a representation in the polynomial. So these are the maths actually we used in AES. Now coming to one example, I think if you have any questions till this section, you can ask in the meantime, or otherwise I can continue with my talk. Then you can ask your questions at the end. So what do you actually want?
Sir, there are a few students who want to ask some questions. So should I unmute them, sir? With your permission.
Please. If they are means.
Okay. So students, kindly message in the chat box so that I will get to know that who wants to ask some questions to the sir. So I'll unmute them.
Diva is there. Actually, raise hand. So
yeah, Divya. Yes, sir. I'll. Divya, now you can unmute yourself as well.
Okay, sir. Good morning, sir.
Good morning.
Sir, I myself Divya Gupta. I am from BSc third year.
Yes.
Sir, I wanted to ask, like, when you told in hyphen cipher that we convert any word, like you converted the college word into numeric form. Sir, how did you do that?
Yes.
Is there some fixed format, or it is like randomly?
No, it's a fixed format. If you follow my actually the talk, what I mentioned, that you actually convert A by 0, B by 1, and C by 2, and so on. So there are 26 alphabet. So if you actually replace A by 0, B by 1, C by 2, and so on, you will actually achieve that Z will be replaced by 25. So this Z26 actually we have taken in such a way that we can cater all English alphabet. If you want to cater in our Indian languages, then we have to move from Z26 to say Z38 or Z40. Okay, so there are more number of letters in Hindi than in English. Okay, so that is the main conversions methodology. Just you write English alphabets A, B, C, D up to Z, and just replace A by 0, B by 1, and C by 2, and so on. You will just complete this process by replacing Z by 25, and any elements from 0 to 25, I can actually arrange those elements as an element from Z26. Have I answered your question?
Yes, sir. Got it.
Okay. Now you can actually remove the raise hand button. Okay, thank you. Anyone?
Yes, Dhananjay sir. Actually, one of student sent me a question.
Yeah.
And he said that the map defined from Z26 to Z26, that is defined as phi of pi as equal to API plus BI. Is it necessarily V homomorphism, or it is any arbitrary map?
This is obviously not homomorphic. Whether this map will be homomorphic, it's an affine map, obviously. But if I go for that, means if that B is not there. Okay.
Yes.
So homomorphic means have I means the phi of x times y. Can I have phi of x times phi of y, or phi of x plus y? Can I have phi of x plus phi of y?
It's 11 hours.
Obviously, you can just compute it separately. You will find that that will not be there. But affine, obviously, this is affine but not linear. Linear means if I remove that constant b there, then that map will be linear. So I don't know means who asked that question. So whether I have given the answer, or even if you have any doubt related to these questions, you can just directly send me mail. Okay, because you are not there. Okay, Harinder is there. Who
Good
raised
morning,
hand.
sir.
Yeah, good morning.
Sir, my question is, sir, what are drawbacks of polyalphabetic cipher?
Yeah, polyalphabetic cipher, because means in that case, this is a good question. So obviously, so polyalphabetic cipher, if you notice that we actually break our plain text into certain number of length, something like which I have given you example. I break my means input into 3 character block. So if anyone actually get that length, what is the length of my block? Then if you notice that if I write the whole plain text into that size of block, so each column actually give you the your monoalphabetic cipher. Are you getting my point? Or otherwise I have to move to that slide. So what I can actually go, I can directly go to that slide. Okay, so here actually I have. Yes. So here you notice that if I actually divide this character E, so now just notice that your E, R, L, and G, if I collect this as a column, so this column actually become a simple monoalphabetic cipher. Similarly, your T, N, L, H, it's also a monoalphabetic cipher. So the drawback of this type of polyalphabetic cipher is basically if an attacker actually get hold of the length of the block, then it is nothing but your monoalphabetic cipher column wise. So that is a drawback of this type of polyalphabetic cipher. So that's why we move to the block cipher. So in the block cipher, you will not have such type of means. Okay, so any further questions, or we can move to our next part?
I think that there is one more question from an MSc student, Kamalpreet Kaur. and she
Something
wants.
about Bitcoin. How does
Yes,
it works? That's
yes, sir.
all. Okay, we can discuss this part, Bitcoin. So just wait for, because in Bitcoin we actually require means that public key concepts as well as cryptographic hash functions. Okay, we will come to that part, but that Bitcoin part is not actually covered during this point of time. Okay, is there any related questions for these two sections actually, introductions and algebra for symmetry key?
Yes, Alka ma'am. If there is any question on YouTube, then please ask.
Yeah, or you can actually type the questions in the chat box. I can give you the answer through that also. Is there any questions from the YouTube viewer? That I will not be able to actually see. So
I think, sir, there is no more
yeah,
question.
no questions on YouTube. Okay. So
So please proceed, sir.
can I move for the next section?
Yes, sir. Sure, sir. Sure.
Okay. So this is the last sections, and if time permits, then we will actually go to the what should be the practice you should follow. Okay. So I will just give you just one more example how actually cyclic group is used to design such type of public key concepts. So first is basically your say this. So I hope means your second year students and second, third, and fourth, obviously from second year students, they know what group is and what the cyclic group. So suppose G with respect to this binary operations dot forms a cyclic group, then we can always have a generator of that group. Assume that G is the generator of that group. G is a generator, not the, because there are many generators. So there is an important concept that you should write a, not the. You cannot have that unique generator for a cyclic group, except that group itself is basically identity. Okay. So this is a cyclic group and G is a generator of that. Okay. So I move to that part. Okay. Just give me a minute. What happened with that?
Hello, Dhananjay sir.
Yeah.
Yes, now your screen is visible. Actually, for
Yeah. Actually means that key was that part. Okay. Now it's visible. Okay. So basically G is a generator of that group. Then what is that meaning? Mean each and every element of G, I can write that element to the power of G. So something like if I take H as an element, arbitrary element in G, then there should exist a integer T such that G to the power T is basically H. Okay. So this is basically the concept of cyclic group. Now, how this type of cyclic group actually used to share the key, secret key in a different locations. Not means for the case of your private key communication, you have to either meet personally before beginning of your communications, or you should have a trusted courier, so that using that trusted courier, you actually send your key to that person's. But here, without meeting any individual personally, I can share my secret through our public communications, and we can use those keys to communicate privately. So just remember these concepts, and actually we call this is a discrete log. Why? Because in this format, since G is a cyclic group and H is any element and G is the generator, then I can always have, according to the maths, that there should exist T such that G to the power T equals to H. Now, what is the problem? If I give you G and I also give you H, and the size of this group is too large, then finding T is very difficult. So there does not exist any efficient algorithm to find this T for an arbitrary H when I am giving you this G. So if I know T, then it's easy to compute G to the power T as H. But if I don't know, if I give you the A and G, so it will be very difficult to find the T. So what is the T in the continuous case? If G to the power T is H, then I can represent that T is basically your log H to the base G. So this is called the logarithm. Now we are actually considering our domain is basically discrete. So that's why we say that this is a discrete logarithm form. So the concepts here that finding T with knowing that G and H, it is very difficult. So with that concept, actually Diffie-Hellman key exchange based on that protocol. So what is this actually? If you notice that, yes. Now, what is the setup? Take a P, a large prime. So nowadays we are taking such type of prime P is basically of size say 300 digit. So what does that mean? Means if I write down this P as prime, so you have to actually write it down using 300 digit number. So this is a 300 decimal number. Then since this is a prime, so you know that ZP star forms a cyclic group. So this is basically for your second year above students. So if P is a prime, then ZP is a ring and ZP star, just remove the 0 from that ZP with the multiplications operations. So that modular multiplication, this forms a cyclic group. Okay. So now if this is a cyclic group, according to the theorem, I can have at least one generator of that cyclic group. Because this is a cyclic group, say that alpha is a generator of ZP star. Okay, so these are public. So what are the public statement? You can publish your P, you can publish your alpha, the generator. Now what, suppose I am here in the sending end and you are here at the receiver end. Okay, so what I will do at the sending end, I can pick arbitrary any number X from ZP star. Okay, so I will take any arbitrary number from ZP star and I just call it this is X, and that X should be kept secret by me only. Okay, now with this I can compute alpha to the power X mod P, that is easy. Okay, and I can send that alpha to the power X to you through open channel. Now anyone, if he or she is actually looking this element, so he will actually get the value of the alpha to the power X and alpha he knows. So without this, of if P is basically 300 digit prime, then knowing alpha and alpha to the power X, it should not be actually find out the X. So knowing alpha to the power X, it should not be possible to get the secret of mine. Similarly, at your end, you will pick a Y that is also arbitrary from an element of ZP star. Compute alpha to the power Y and send it back to me. Okay, so I actually don't know what Y is and you also don't know what X is. But after these two communications, we can actually arrive a certain secret that should be a common secret between you and me. So what is that? I know alpha to the power Y because you have sent me that alpha to the power Y through open channel. And I know my X. So I only can compute alpha to the power Y whole to the power X because X is known to me only. So at my end, I can compute this, and what will be this value is basically as a mathematics form, I can write it like alpha to the power XY mod. Okay. Similarly, at your end, what you will do, you received alpha to the power X from my side and you know what Y is. So you can actually compute alpha to the power X whole to the power Y. Okay. So you actually receive alpha to the power X. So after these communications and with these computations, we can arrive a common secret key. That key can be used as your AES key. So this is actually solves the key exchange problem in the symmetric key setting. So this is basically the first door opener for your public key cryptography. Okay, so these are the applications of your means group theory in public key setting. Similarly, you will have applications of ZN star with that multiplication in RSA. So you can just go through it. I am not going to discuss this detail. So it would be better if I actually move to that what you should follow during your this online communication. If you means what is this is actually open for the discussion. So what you want, actually I can go either discussing the applications of algebra in RSA and Intro, or I can move to the practice you should follow for your online communications. This is open. What you want, I can cover that part because we don't have time more than 20 minutes or 15 minutes. Okay. Any questions or queries? What will be the option?
Yes, sir. Sir, am I audible?
Yeah, you are audible.
So, Rajesh sir, please, you can proceed, sir.
Proceed to the practice to follow or for the maths application?
Okay, dear students, what is your choice? Actually, sir have given you two options. Either they want to proceed for the practice, or other the second session of this presentation. So, okay, you can send your opinion on chat box. Okay, sir, they want to practice to follow.
Okay, so now I can move to this practice to follow. So since just before going to the practice to follow, so whether your this semester is throughout online or you are actually means giving the students or allowing students to come to the campus.
No, sir, this is online semester.
This is online semester. Okay,
yes.
so that should be useful for both, not only for the students but also for the teachers. So what should you follow during your online communication? So there are few best practices. So please follow such type of protections because you actually just reduce the chance of attack through our this type of scenario. So what you should protect your data. Avoid pop-ups or unknown emails and links. Something like if you go for a new site, you will often notice that there is a pop-up. Just accept the notification. So why we please do not just accept such type of notifications if you really not require such type of notification. Okay. Please do not open any unknown email. Even if you are opening that unknown email, please do not click any link sent through that email. So please avoid such type of scenario. Means if you don't know the sender, then please do not open any link or any attachment in that mail. Use strong password protections and authentications. Obviously, please use such type of rules for your password protections. I will come to that part. Okay, password in detail. How should be your password? Connect secure Wi-Fi. Please do not use any free Wi-Fi, something like your railway stations or in your airport or anywhere. So Wi-Fi is free does not means it will be secure. So it's actually accessing your data. So please do not use your free Wi-Fi. Enable firewall protections if possible in your institute also as well as in your home. Invest in security systems. So please do not use freely available your antivirus, something like that. Okay. Install security of software updated. Obviously, whenever you actually just receive the notice to update your system or update your apps, please update that. Talk to your IT department. I don't know whether you have that IT department and that. So if there is a certain dedicated IT team are there, so please talk to your IT department if you have actually noticed certain malpractices there. employ third-party control, and obviously embrace education and training. So that is required for both, for your students as well as your teacher. Okay. So next, what should be your strong password? So please do not use personal information in your password. Please do not your birthday as your password, or just like most commonly used password 12345 or QWERT, ABCD. Please do not use such type of password in your any online secure connections. Do not use real words. Something like you avoid using the dictionary word as your password. So what should be your basically the choice of the password? You just take your favorite sentence. Something like if I take modify easy to remember phrase. So using this sentence, I can generate a password. Something like I can just take METRP. So this will be my password. So take your favorite sentence and you just take the first letter or say second letter of each and every word of that sentence. So that will be a very good choice for your password, because that word will not be form of a dictionary word and it will be very difficult to guess for that approach. And don't write down your password or pin anything on your device. Please do not write your password or ATM pin on mobile or on your laptop. Okay. So change your password on regular basis. So that is the recommendations for the government side, but I don't actually believe such type of recommendations. So what you should do, you use a strong password, then do not require to change means regularly. Because if you want to change regularly, so normally by human tendency, we actually follow the pattern. So we do not actually change our password. We just add few suffix or prefix with that password. So there is basically a pattern we follow while changing our password in regular basis. So use different password on different accounts. That is very, very important. Please do not use your same password for your Gmail, online banking, LinkedIn account, Facebook, WhatsApp, and so on. Because if someone actually gets hold on a particular account, then almost all your account will be broken. How? Because in every site, normally what you use as in your username, you basically give your mail ID as your username. So I can get your email ID from anywhere, and if I know one password of yours, then I can actually get access to each of your online sites. So please use different passwords for different accounts, and do not obviously type password on device. That actually I mentioned that part. So please do not write, or even if you don't follow any network, something like you don't please access your internet banking through either any cyber cafe or anywhere. If you want to access your bank account, say you are in outstation, so use a dedicated app from the bank itself for that type of purpose. But don't go to the cyber cafe to actually access your banking. Okay. Mobile device security, obviously use a strong password. I have mentioned what should be the procedure to create a strong password. Use biometric whenever possible. Nowadays, almost every smartphone you will have that biometric features. So use multi-factor authentications, meaning you use biometric, you use PIN, and you can use also pattern. Okay. Use multi-factor authentications, ensure public or free Wi-Fi protected. So you do not actually give the access to the free Wi-Fi. So please do not actually use, even means whenever you are not actually using the Bluetooth applications. So please do not open that Bluetooth. Disable Bluetooth connectivity. Use VPN, and obviously use your antivirus. So if you are using this type of antivirus, so please do not go to the freely available antivirus from the site. Encrypt the mobile device. Nowadays, almost every smartphone you will have that encrypted options. Disable autofill. Yes. How busy you are, please do not give access to autofill. Something like if you are actually going to just start your banking transaction, and many a times you actually follow the autofill that ATM, that password or PIN actually sent by, or OTP actually sent through the bank, you directly autofill to the app. So please do not do such type of autofill. Okay, and use trusted app. That is a very important. So please do not use any app which are actually showing through the advertisement. If you want to use the trust app, then use the trusted app from the original sites or from the Google Play Store. Okay, so these are the few steps, and obviously if you have such type of features in your Gmail also, this is freely available. Use two-factor authentications, meaning if you actually enable this two-factor authentication, whenever you want to use your Gmail access either from a different device, then actually Gmail will send you some other notifications. So nowadays they are sending the graphical image that you are accessing with this device, whether you are there or not, your mobile you will receive that type of message. If you press this yes button, then actually you have that access. So use two-factor authentication, that is freely available. You don't have to pay any more extra money for that. They are actually provided by Gmail. Even nowadays in all mail, you will have this two-factor authentication. Even in your WhatsApp, Facebook, LinkedIn, everywhere, you can enable this two-factor authentication. Okay, so two-factor is basically multi-factor, something like something you know, that is your PIN, password, or pattern. Something you have, something like your ATM card, you have that type. Mobile phone, okay, something you are, that is your biometric. If there is options for the biometric, please go to the biometric options, that is better. Okay, now for internet banking, obviously I mentioned that few parts. Create a strong password, change it regularly, check your bank account frequently, means if something happened on your account, please immediately inform to your branch. Okay, so that means also that branch manager can also notify others related to such type of attacks. Okay, use secure and trusted network, which I actually mentioned that while actually using your internet banking. Always log out your account. That is very important part, because if you don't log out on your online banking account, there is basically, you will notice that there is a 3-minute window. So in that 3-minute window, any attacker can actually get access to it. So if you are actually just open the internet banking, use that app while actually completing your activities, immediately log out from the internet. Okay, enable multi-factor authentication, that is obviously, and please be aware of the phishing email. So bank never send you to just give you the PIN number or your ATM card detail or anything related to that. So please avoid such type of phone calls or phishing attack also. Please do not open any link you are actually receiving that this is your SBI banking link. Just go through this link and you will have certain type of discount. So please do not use such type of link. If you want to actually avail this online banking facility, please go to the direct banking site without taking any means response from your mail from your inbox. Okay. Yes, you have to follow certain good cyber hygiene tips. So install reputed antivirus and software. Obviously, I am not naming it, but you know what this reputed antivirus nowadays. So then use network firewalls, update software regularly. That is also obviously an important point, because if there is an update available, means the previous versions, there are some loopholes. So that's why they have actually updated. And set up a strong password or passphrase, use multi-factor authentications, employ device encryptions, backup regularly. Yes, you please take your backup so that if something happened, so you have such type of data in your backup. Keep your hard drive clean if you are actually selling your laptop, tablets, or smartphone. Secure your router. Obviously, that is also one important part. Okay, so these are the basic few references. If you are actually interested in this type of topics in your detailed study, so please follow these two books. So this is one of the best book I can suggest for your third year and above students if they are interested, and if you can actually give the electives. So the third year students can take cryptography as an elective for one semester course. So many universities actually nowadays are following. So this is one of the best book for the maths, cryptography theory and practice by D.R. Stinson. And you can also follow this book. So algebra for applications. So there are a lot of applications you will find that not only cryptography, but secret sharing, error correcting coding. I have mentioned that part, that finite field. There are a lot of applications of finite field in error correcting coding, fingerprinting and compression, something like your encoding technique. Okay, and these are the basically a few books. If you are actually just interested, something like your novel. So this cryptography, so he explained this cryptography without using I can say at least a minimum number of use by maths. So this is a very good book. You can just go through that cryptography. And another, these are the basically novels. If you are interested, that what actually happened before 2013. So that Edward Snowden revelation. So there are a lot of books related to this. And the security tips actually I have taken from these sites. So cryptogram, it's freely available. You can just go through this cryptogram link. You can just write down your email ID. You will get newsletter, fortnightly newsletter, means you will get 2 newsletter per month. And Naked Security, the Register and JDNet are very good sites. What you should follow for your practice in online security. So that's all from my end. Thanks a lot for your attention. And now I I am open for the questions, comments, or suggestions. Okay.
Hello. Hello, sir. Sir, thank you so much for such a nice talk, sir. I'm a faculty here, sir. I am having a few questions. May I, sir?
So, can I actually move from the presentations part, or?
Yes, sir. You can remove your presentation part.
Okay.
Yes, sir. So, may I, sir? Sir, can
Yeah.
you list some good VPNs that has to be used while conducting online teaching or something?
Yeah, online teaching nowadays, you actually just go through the Google, you will find that VPN.
Okay.
And obviously means I can communicate with this if you are actually recording, so I cannot suggest the name because
Okay.
this is in the record. Just please write me or send me a mail.
I'll write
Yeah,
you
I
an
will
email,
give
sir.
you
Either I'll message you in a WhatsApp or something. We can use that media to.
yeah, means either WhatsApp, or you can send me mail regarding that VPN.
Yes, sir.
Any
Sure.
other related to this, which will be an open discussions, we can discuss it here.
Yes, sir. Secondly, sir, I want to know that if I'll save some data in a draft mail and I'm not sending it to someone or some person, but it will be, I'll kept it as in my draft. So is it safe or not? Matlab, like if I am stored some data in my Gmail draft box, then matlab, how we can ensure that it's more secure than in some other place or something?
Yeah, means nowadays you know that that anything we are actually using, they are actually stored in the cloud.
Yes, sir.
Even
Yes.
in your Google Drive also, everything is there in the Google Drive, something like your Google Cloud.
Yes, sir.
That is obviously one thing you remember till this part, anything online, we cannot say that is secure.
Yes, sir,
Yes, but what we can do, we can use the best practice. So anything, if you want actually to just post a picture or anything,
anything, yes, sir.
just one time, you cannot have to say that that picture is basically secure. Something which happened before 2013. If you actually go through the news that Edward Snowden, who is now in
Yes, sir,
Russia,
Edward. Yes, sir, now in Russia, yes, sir. There is a
so
cyber.
you know that what happened actually in the Google case also. So
Yes, sir.
before 2013, what was the practice in the Google? So Google actually, while in the transit, they are actually showing that this type of communications are secure.
Secure,
But
yes.
while storing the data in the cloud, so they are actually stored all the data in the plain form. And NSA actually access that plain form where they are storing their data. So even if you are communicating using your secure encryption, but at the storage time, actually you have that access in the plain form. So there is a lot of gap between theory and practice.
Yes, sir, I
Okay, so it
understand.
is better. Please do not even for your means student. This is also means recommendation. Please do not use your Facebook for a public domain. If you want to use Facebook, yes, you use it, but do not give access your every data to everyone. If you want to give access, please restrict it only for friends, not friend of friends and anything, something like that. So please control such type of security policies at your end.
Sir,
Okay?
one more question. I want
Yeah.
to know that like earlier we always used to use at Hotmail or Rediff mail,
Yeah.
and now currently we are all mostly we all are using I think Gmail platform. So which one is more encrypted? Which one is more trusted? They have the encryption certificate with them. I think
Yeah.
Google.
Now basically the question is obviously nowadays from means I can say 2018 onwards, almost every email, something like your Hotmail, Redmail, Gmail, Yahoo, all are using encrypted. That is in theory, obviously.
Yes, sir.
What we actually believe, and they are actually publishing the white paper. So in every email, you will get that what is the encryption's methodology they are using that is written in the document. So you will have that white paper in the Google also, Yahoo, Rediff, and means Hotmail. So nowadays, from 2018 onwards, almost everyone using TLS 1.2 at least. So now Google actually moved to TLS 1.3, but remaining most probably Rediff and Hotmail. But I have not checked that Yahoo. So they are actually using TLS 1.2.
I think Yahoo is also using the TLS 1.2.
Yeah, so TLS 1.2, but Google actually moved to TLS 1.3.
1.3. Okay. And sir, my last question. Sorry to disturb you.
Yeah, please.
I have read in coding theory in which matlab in our subject we read about the linear codes. But is there some work is going on the non-linear codes as well?
Non-linear code means you have to check, but I am not also sure. But there are a lot of applications of coding theory in current scenario, that is post-quantum cryptography. So
Okay,
you can just go through the post-quantum cryptography competitions by NIST.
okay,
So you will actually have lot of applications. There is a one complete branch that code-based cryptography. So code-based cryptography are basically will be secure in our post-quantum world also.
okay.
So nowadays there are a lot of news going on that quantum computer is coming. So what will happen in our traditional cryptography?
Yes, yes, yes.
Okay.
Okay,
So
sir.
there is a means complete total different branch. Code-based cryptography now is one of the most important part for your encryptions in the post-quantum world. You can just go to the NIST site, NIST, National Institute of Standard Technology of US,
Okay,
and
sir.
there is a competitions going on
Okay,
post-quantum cryptography.
okay, sir. Okay.
Now Harinder actually raised hand,
Yes.
so
Thank you so
Yes,
much, sir.
sir.
Yes, sir. In the
Yes, sir. As you said, sir, we have to use a different password for the different accounts and put a strong password also. Sir, but in this digital era, we use many accounts, sir. So,
Yeah.
using how to remember that that type of strong accounts, because we can't save them in phone and can't write
Yes,
any
this is a very good
them.
question for all. Means not. This is really a very good question. This is a normal problem for as a human being. Suppose I have to access say 4 or 5 different sites, and I have to remember 4 or different means passwords for those sites. It will be very difficult for a human. So first thing, if any site provides you that you can use OTP. So first go for the options OTP. So nowadays many sites you actually have that you don't require a password. You have that options just while signing in. They actually ask you whether you want to send the OTP in your mobile or not. So if that is there, so please use OTP. That is the best option. Next, if you have to use the password for different sites, then what you will actually do, you use a passphrase, not password. Something like, just for an example, I am giving you something like my ABCD is my passphrase. Obviously, and please remember one more thing, that you should use the length of the password should be at least 14 characters. Okay, 14 character means your means that should include your small case, means uppercase, lowercase, at least one number, or another is symbol, something like exclamation marks, at the rate, hash, dollar, something like that. So your password should be in the combinations of this. Create a strong password first, a passphrase, something like, just for example, I am created my passphrase like ABCD. Okay, now this is basically my password for my Gmail. Now what I can go, I can use this passphrase as it is for my Facebook. In that case, what I can actually, I can either append some suffix or prefix, something like ABCD in my password for the Google. I can actually use ABCD Facebook 2020, Facebook, something like that. So that should be there in the either prefix or suffix. Similarly, if you move for your LinkedIn, so you can actually use LinkedIn, that passphrase 2020. So include those type of site dependency so that you can actually remember that my passphrase for LinkedIn is this, passphrase for Facebook is this, and so on. Are you getting my point, Harinder?
Yes, sir.
So this should be the practice. Okay.
Sir,
Yes.
sir, I request you to share slides, sir. Slides
Okay.
means after that.
Okay. Share the slides. I will share the slides with Dr. Sandeep. Most
Yes,
probably,
sir.
Dr. Sandeep will share with you.
Yes, sir. Yes, sir. I will share the slide with my students. And sir, I have a request, sir. Please share the first page of your slide because our IT department is requesting for that.
First page of the slide right now.
Yes, yes, sir. Yes, right.
Okay, okay. Just a minute. Okay. Okay, actually, just give me a minute. Actually, I closed this presentation. So I
Sure,
have
sir.
to go for that.
Okay. Now I would request my colleagues, Dr. Alka and Dr. Baljinder, if they have any question, then please recite these questions.
So whether it is visible now?
Yes, sir, it's visible. Sir, there is a one question from our student Mamta Verma. The question is that, sir, is biometric is safe as it is related to Aadhaar and our privacy?
No, questions. Please repeat the question.
Yes.
Yeah, there are
So the
basically
question
two
is,
questions inside that one questions, I hope. Yeah.
yes, sir, there are two questions. Is biometric is safe as it is related to Aadhaar and our privacy?
Yeah. So, okay. What I have said during the presentations, one is related to the biometric. If you are using biometric for just accessing your account, then obviously it is safe. Okay, one thing. Next, the biometric used in your Aadhaar, actually, this is basically a data converted in your biometric image. So in Aadhaar, there is a different mechanism to communicate the biometric to the authority. What that means, you actually give your fingerprint while just applying your Aadhaar card, and you give almost every detail. So those all details, your personal details, your biometric and everything are stored in a single file, and that file actually encrypted. Okay. So that encryptions, according to the theory, it is safe. Okay. Now what happened? Because you notice that there are a lot of news related to the leakage of this other data. What happened in the practice? While implementing this Aadhaar as its practice, government hires few contract technicians. They are not actually employer of the government. So they are basically just hired for say 6 or 7 months. So what they actually did during that practice, they leaked from their end by either verbal communications or just to get extra payment. Suppose I am in Airtel. So if I actually have access to every data, then I can use those type of data in my business. So I can pay such type of contractor some extra money. For that extra money, actually those type of contractors reveal the data. So in practice, there is this type of gap. But in theory, if they have implemented such type of data in the Aadhaar, then that should also be secure. Uh, have I given you the answer? Okay.
Yes, I got that.
Any further questions, or now I can stop my session?
Yes,
Sir, I had one question.
yeah, sure. Ravi.
Sir, like government is promoting digitalization today in these days, but we know that our data isn't safe with anyone. Not if we cannot even trust the government because they might leak our data due to any certain reasons. So, is it beneficial towards moving towards digitalization?
Yeah, this is a very good question, but obviously just remember that if you actually want your convenience, then obviously we require this digital communication. But what should follow? Obviously, that depends on the government. If they implement the exact algo as it is written in the theory, then there is no flaw in that. But obviously, just I gave the example. If that contract persons does not know anything about cryptography, they just suppose I gave them this algo to implement. So as a computer science point of view, they just implement the algo without noticing what actually the drawback if you use this type of algo in your implementation. So there is obviously a lot of drawbacks between theory and practice, and I cannot say that everything is secure. I already mentioned that anything in digital, I cannot guarantee you that that is secure, obviously, but that security in practice, the user should also take certain steps to secure yourself.
Hello,
One
sir.
thing, yes, just one
Sir,
sentence, and please ask. Just one thing, obviously, you know that such type of digital communications we require. Nowadays, if we do not require such type of digital communication, then we cannot have such type of webinar in today's scenario. So there are a lot of advantages of digital communication. Just noticing that because of the few drawbacks, we actually stop our communication. Yes. Yeah. Now open for the questions.
Dear participants, kindly raise your hand and I'll make you unmute so that you will have discuss your query with the sir. Okay, so
Yeah,
Sandeep
there are
Das?
two. Actually, one is Sandeep Das, another is Sukhdev. So
Yes, sir. Yes, sir. Sandeep Das, you can now unmute yourself, please. Yes.
Sir, good morning. Sir, my question is that where you are saying that for security purpose we can use the VPNs, but the thing is that some of the VPN are free and we know that they are not safe. But when we use some VPN with a subscription, then how we can assure that our data is safe? Because the owner may have some reason to sell our data to the government and some other authorities. How we can guarantee? How we can ensure our data is safe in the hands of VPN owner?
yes, this is obviously, just remember just my sentence. If you actually use VPN or antivirus, use the reputed versions that company actually offering, that company is reputed. Suppose if that type of reputation is there for the company end also, so you can trust them because they don't actually want the loss of their profit. So suppose, for example, means I am not saying, since it is in record, so I am not saying the name of the company. Suppose a company uh, A is basically the one of the best company for antivirus, and if you trust that A and you find certain flaw on that A company, so what will be the happen to the business of that company A? Obviously, it will fall down. Something like that example I can quote, that in US, a terrorist actually means arrested by that CIA, and terrorist actually using that Apple phone, but Apple did not provide the informations related to that communications on the mobile to the US government also. Because if they actually provided that type of scenario, then obviously the company loses many means business. So that type of trust one should follow from a reputed company. Okay. Yes. Next, Supinder or someone like that actually.
Quick call, I think, sir. To PUID.
Okay, Sukhdev is there. So please unmute and you can ask now. And that would be my last question because from 12 o'clock there is another meeting. So, okay.
Sukhdev, you can unmute yourself, please.
Sukhdeep,
sir.
please ask your
Yes, sir.
question.
Yeah. Sir, I just want to say when we don't have a proper uh, platform, digital platform, where we can assure the security of our citizens, even the WhatsApp chats are being released of such big slabs, then how can a simple person can trust that this social media, this online platforms that he or she is using will not used to harass that person in future?
Yeah, this is a very good question. Yes, obviously means this is a question for any common citizen. Now, what we actually follow? Use your social media platform in such a way that it should be an effective communication. Why you require? Just not for you, it's basically for anyone. Why I require to give my every each and every detail with just clicking the picture or the place and upload it on the site? Why actually I do require such type of activities? So as a user also, we have to take that such type of precautions. Suppose I am there, means I am just, for example, just if I go for a trekking and I just click that picture and I just in the below I write that captions, I am in tour from this date to this date. So anyone seeing this type of post, if you want to post such type of scenario, so please post it only for your friend. Don't make it public. If that is public, then anyone actually following me, so he or she will be able to notice that I am not in the city for these many days. So anyone can attack my system. Okay, so please follow certain types of rules. Even the following certain type of rules, you will get notice that there are some type of scenario in the online activity. Nowadays, there is a cyber cell. So please, if such type of happens in you, immediately report to your cyber cell. There is a, obviously in every city, there is a cyber cell separate branch. They will actually keep your identity secret and they will solve your problem. So if such type of means situations happens to any one of you, just don't avoid to report it, because many a times what we do, actually just what happened in my name or in my family, we normally don't go to the reporting such type of cases. So better to report in the cyber cell, not in the police station. So there is a, you will notice that in the government also there are dedicated cyber cell there in every city. Go to that cyber cell, report your means incident, and they will actually keep your identity closed and they will solve your problem. So this is obviously a big challenge. We should actually follow certain type of practice and we actually remove such type of activity. Hope I answer your question.
Yes, sir. Thank you, sir. Thank you for answering the questions of our students. And now I would request my colleague, Dr. Amandeep Kaur, to say a vote of thanks to our speaker. So, Dr.
So
Amandeep.
can I now close the presentation?
Yeah, sure, sir. Sure.
Okay.
Dr. Amandeep, please.
Sir, my voice is audible?
Yes, sir. Yes, ma'am.
So, Honorable Vice Chancellor, Professor Gurmail Singh Sir, and my dear colleagues, participants, and my dear students, on behalf of Akal University Batinda and its entire fraternity, I, Amandeep Kaur, feel immense pleasure to take this opportunity to propose a vote of thanks to our respected and eminent speaker, Dr. Dhananjay De, who spared the time from his busy schedule to grace the webinar with his important and extremely relevant address on modern algebra in real life. So, Sir has introduced very nicely the subject cryptography by highlighting the application of pure mathematics, like as modern algebra, number theory, that how the cryptography is important in real scenario. So, Sir has discussed very nicely the communication process, how it works by encoding, decoding the message, which loads lot of mathematics. Also, Sir has highlighted the application in real scenario, that one can say that the security in internet banking, in HTTP websites, as well as Aadhaar card, ATM machines, and even today's mobile communications. So, Sir has also discussed the cybersecurity, the best practice which we can follow in today's online platform. And Sir has highlighted the tips for best internet banking and best cyber security hygiene. So I'm sure this webinar motivates our students and all the participants the importance of the cryptography in real life. So I thanks again to our speaker for his valuable and fruitful discussion with our students as well as the participants. So I would further extend my heartily thanks to our Vice Chancellor, Sir, Professor Gurmail Singh, Sir, for his always encouraging us and providing the opportunity to organize such good events time to time. And I take this opportunity to especially express my deep regards and gratitude to the convener, Dr. Sandeep Sir, coordinator and head of the department, Mr. Rajat Sir, and organizing team, and my dear colleagues for their endless effort to make this event successful. So my deep sense of appreciation and thanks to all the participants and our dear students who chose to be live with us and attended this webinar with their great enthusiasm and made it as a successful event. So also my sincere gratitude to the technical staff who help us to organize this event on this online platform. So once again, I thank you all for being with us and have a wonderful day. Thank you.
So thank you, ma'am, and thank you, Dr. Day, for such knowledgeful session. And hopefully, when once things get settled, and we have pleasure to invite you physically in our university. Thank you, sir. Thank you for sparing time with us. Okay, now I am going to end the meeting. Okay, thank you. Thank you.